Hello learners, welcome to chapter 12. With the pictures on the screen, you can easily make out that this chapter is electricity and circuits. For our understanding, we are going to divide it into two parts and this is going to be part 1. But before we proceed further, please like, subscribe and share the channel, and your action means a lot to me. The learning objectives for this chapter are: explain electric cell as a source of electricity, to know how the electric bulb works, define electric circuit and know its components, define electric switch, explain how a torch functions, and lastly, differentiate between conductors and insulators. Humans know about electricity since ancient times, but we have been harnessing its power hardly since the last 250 years. On the screen, we see one of the most popular graphic showing the use and spread of electricity across the globe. We can easily make out that still a lot needs to be done. Benjamin Franklin's experiments with the electricity opened up a new avenue. He performed his famous kite experiment in the year 1752. Later, in 1831, Michael Faraday discovered the principles of electricity generation. To amazement, the same principles are in use even today, but on a very large scale. Electricity is a convenient way to transfer energy. It can be easily converted into sound energy, wind energy, heat energy, and light energy. At the same time, it can operate a number of electronic and electrical devices. Electricity in India was introduced by the Britishers during the colonial period. Calcutta was the first city to have electricity in the year 1879. Prior to this, houses had kerosene lamps. And now, when the electricity goes off, we have torch, which are operated by electric cells. We even have a handy torch on our mobile phone these days. This helps us to see in the dark. Torch has a bulb and uses electricity. This electricity is supplied by the electric cells. Now let's discuss about electric cells. Electric cell. An electric cell is a device that produces electric current from the chemicals stored inside it. So basically, electric cell converts the chemical energy into electrical energy. Here we have an image of the electric cell. It has two terminals. One looks like a metal cap and is called the positive terminal. Other looks like a disc and is called negative terminal. Electric cell is of two types, primary cell and secondary cell. Let's have a bit more description about both of them. So first we have primary cell. Cell that converts chemical energy into electrical energy by irreversible chemical reactions. That means these cells cannot be recharged. Here we have some examples: zinc carbon cells, alkaline batteries, and primary lithium cells. There is a note. When the chemicals in the primary cell are used up, it stops producing electricity and requires replacement. Secondary cell. Cell that converts chemical energy into electrical energy by reversible chemical reactions. That means these cells can be recharged by passing currents of electricity. Here we have a simulation showing charging and discharging of a secondary cell. Examples for secondary cell are nickel cadmium battery, lead acid battery, and lithium ion battery. Let's discuss a science fact. Secondary cells be never disassembled, short-circuited, thrown in fire or water, and dropped from height. They may burst or get heated up to cause fire. Caution. Have you seen this danger sign on the electrical transformers or near the electrical power lines? It is to warn people that electricity can be dangerous if mishandled. Never try to work with any electrical wires or sockets at home. Since we know that there are primary cells and secondary cells, for our experiments and activities, we'll prefer using the primary cells. These are much safer to use. Since we are familiar with the term cell, you also must have come across the term battery. Historically, battery was considered to be an arrangement of electric cells which are connected in series or one after the other. Usage of the term battery has evolved to include devices composed of a single cell. Batteries come in many shapes and sizes and can be small enough to fit a hearing aid or watch, thin enough to fit inside a mobile, so they can be seen in the form of a button cell or in the form of a battery pack, and they can be large enough to be used in a vehicle. Electric bulb. Electric bulb is a device which produces light on the application of electricity. It is also known as light bulb and contains a filament kept inside a glass case. This filament produces light and heat energy on the passage of electricity. It is supported by two thick wires, one of which is connected to the metal case and other to the base of the bulb. These two form the terminals of the bulb. These terminals never come in contact with each other. Similar design principle is used while making the bigger bulbs. As a caution, never touch a glowing bulb as they become extremely hot once turned on. Now a science fact. The Sentinel light is the world's longest lasting light bulb. It is burning since 1901 and is in Livermore, California, USA. No one is allowed to touch the bulb or clean it and is constantly kept under camera surveillance. A bulb connected to an electric cell. Here we have an activity with the aim to light up an electric bulb using an electric cell. The materials required are electric bulb, different colored wires, tape, electric cell, scissors and rubber bands. The procedure has following steps. Remove the plastic coverings from the ends of the wires. Fix the exposed part of the wire to the cell terminals using tape or rubber band. Connect wires to the bulb. There are 6 ways to make connections. We will test them all. Different arrangements of electric cell and bulb. Since we discussed that there are 6 ways to make the connections, let's see them one by one. Here we have the first one, wherein metal case of the bulb is connected to the positive and base is connected to the negative of the cell, so the bulb glows. In the second arrangement, metal case is connected to the positive, whereas there is no connection between the base and the negative terminal of the cell. The bulb does not glow. In the third arrangement, metal case is not in connection with the positive terminal of the cell, whereas base is in connection with the negative terminal. The bulb again does not glow. In the fourth arrangement, both the terminals of the bulb are connected to the negative of the cell. Again, the bulb does not glow. In the fifth arrangement, both the terminals of the bulb are connected to the positive of the cell. Again, the bulb does not glow. In the last arrangement, metal case is connected to the negative terminal of the cell, whereas base is connected to the positive terminal of the cell. The bulb glows. Here we have an observation table for all the 6 arrangements. The bulb glows only in the first and the 6th arrangement, wherein bulb terminals are connected to different terminals of the cell. The bulb does not glow if one of the terminal is closed and another is open, and if both the terminals of the bulb are connected to either negative or positive terminal of the cell. With this, we come to an end of part 1 from the chapter Electricity and Circuits. In case you have any questions, please don't hesitate to write a mail to learning.space.mk@gmail.com. There are loads of queries which keep on coming and timely response is being given to them. So we'll meet again in the next part. Till then, happy learning!